So 8.4 would be the section of all sections beyond all any others that would you would feel blessed to have the note card. This is a definite note card full of information section. So like everything before that line, I would put on a note card. Otherwise, these questions I think are pretty impossible. So it's called trig substitution. So the problem is going to be one of three types. Numbers plus variables where they're both squared. Numbers minus variables where they're both squared. Or variables minus numbers where they're both squared. If the problem has the adding version of this, you're just going to do x equals the a, which is the square root of the number you were looking at that was a square. So square root something you can see, and put tan theta next to it. I don't know why this works. I just know that it works. I don't know who thought up this scheme or how or when, but they did, and I trust it on faith. But unlike some of the other lessons, I'm not really sure what the background is on this. Like integration by parts, I was able to show you like it was the product rule, like inside out. This is probably inside out of something, but I don't know. We're going to need to draw a trig picture of a right triangle. So whatever the thing was that you had will be on the hypotenuse, but rooted. One of the legs is going to be an x, and I should mark that reference angle as well. And this would be the number that we had once we rooted it. And somehow magically, this thing that we used to have some adding, we're now going to have a multiplication thing, but it's going to have trig squares in it too, which you might think is worse, but it'll actually be better. Doesn't seem like it'd be better, but it is. Similarly, if it's a subtracting thing, you just do a different trig substitution with sign. You draw a little bit of a different picture of a right triangle, and magically this pops out. If it's subtracting in the opposite order, you do a different substitution with secant. You draw a little different picture and get a little different thing popping out. And you just kind of trust by faith and experience. This is just what you do and what will happen. Question about that in a nutshell? Without a note card, that would be like really a big burden to try to memorize all that. That'd be rough. So here's my cheat sheet. If you like a little recipe of steps, you can jot this in your notes. If you don't like recipes, feel free to ignore this. You don't need to do the recipe. But first thing you're going to have to do is decide what type you have. It has to have plain x squareds. You can't have a number in front of the x squareds. So this is going to be good news. This is going to be good news. This we're going to have to remedy before we can do anything about it. There's a number in front, so we've got to be careful about that. But what type is this? Is this, I'll number them over here, plan number 1, plan number 2, or plan number 3? It is plan 1 because it's added. So I'm going to go x equals, the 4 is going to give us the A. The A is going to be 2 tan theta. I'm going to draw myself a triangle where I've got a root, an x. We just decided that the A was 2. This would be the root of the chalk. 4 plus x squared. So we just chose our substitution. As always, find a derivative thing. Anytime we're doing these substitutions, we've always picked u's and found du. Today, for some reason, it's x's and dx's. But derivative of tan, secant squared. And then we're up to zone 4. We're going to substitute a bunch of stuff in, and we're going to do some simplifying. So the integral I originally had a dx, we just decided that our dx is 2 secant squared. The magic trick of this, where there used to be a squared plus x squared, there's now going to be a squared secant squared. So under this root is where the a plus x squared used to live. That's now 2 squared secant squared. And now we're done kind of like doing new stuff. We'll have one little bit of new stuff on here, but if I had dropped you off with this problem a month ago, you'd have been maybe okay. Anything you could do there to simplify this world?
You make the bottom 2 secant.
Yeah, I would do the root on the bottom to get 2 secant.
It just becomes secant.
Yeah, 2's will cancel. Some of the secants will cancel. We're doing the integral of secant. Integral of secant should be on your card. Integral of secant was in section 8.1 on a page. It had something to do with an ln of bars or something, but I don't remember that one off the top of my head. We're in a part of the book that we just, I don't do this section, this chapter as heavily. Like something that I teach you in September, I use it all year. Something I teach you on May 15th is like, I use it once a year, if that. ln secant plus tan.
Yeah. I have a question.
Yep.
So, way back when we first learned like integrals of trig stuff, I had the integral of secant and secant tan without any ln. Is that like a thing or is that like not?
Derivative secant, the secant tan.
I had the
So
same
the
problem.
integral of secant tan would be secant. Look at 511.
Okay. What's that page with like the box?
Yeah.
Yeah. Yeah, I have that one on my card too, but I just wasn't sure like if the other one.
Yeah, the derivative of secant is secant tan.
Mm-hmm. Okay.
So if we reverse that, the integral of secant tan is secant. The integral of secant, we learned a couple pages later, it's on the bottom of 514. This I just pulled off the bottom of 514.
Okay.
With that. Then this is the other thing that's the new move. We've got to substitute back. The way we're going to substitute back is using the picture. In case you're wondering, why did I have to draw that picture? Well, we're going to need it at the end of the problem to substitute back. So ln, if we just use the picture and Oscar has his heap of apples, you know, opposite, adjacent, hypotenuse, that kind of thing, how would we grab secant? Which fraction would we make for secant to be a thing? So the root over 2. And then tan. I'll throw on plus C and draw a line and call it a day. You could write these as a single fraction if you wanted to, because they already have the common denominator. So if you wanted to do a nice long fraction bar, this plus that, all on top of the 2, you could do that. That wouldn't like hurt anything. If we were sure we had a positive, we could drop the bars maybe, but we really aren't. Question about that one? So this one. Decide on what type we have. It's a subtracting, so it's either type 2 or type 3, depending on order. And it is type 2, because it's numbers minus variables. So numbers minus variables were type 2. So x equals, the a would be 3 tan theta. While I'm there, let's go ahead and just do the dx. What's the derivative of tan? Secant squared. Draw myself my triangle that I'll need later. And I did the wrong thing already. What did I do wrong?
It's supposed to be a squared minus x squared, so it's 310, or it's 3 sine
It's
theta.
sine, yeah. I grabbed 10 from the top line. We're doing substitution number 2, so I need to grab that 3 sine theta. And the derivative of sine
Cosine.
is cosine. Then I want to grab the middle picture that has an x. This would be 3. This would be a root that has and then we've got a new integral. So on the bottom, this is where we focused at first to decide on our problem type. This is where we're going to do just our magic trick. This, like magic, because the notes in line 2 say so, becomes a squared cosine squared. So under this root, there's a 9 cosine squared. This x needs to get replaced. So we look to this. X is going to live here, but we've got to square that. So 9 sine squared. The dx we grab from that, so that's a 3 cosine theta. And then we're done doing new stuff for a second. Question about all the comings and goings there? Clean up a little bit. Make the root go away. 9 becomes 3 cosine. That 3 cosine could cancel that 3 cosine. So our new integral, I'm going to slide the 9 out of my way. And we're trying to do the integral of sine squared. I think the integral of sine squared is on our card. I think at some point we did that. That was probably around that same. I think that's, I don't know, it was earlier. It was somewhere. But I got 9, and then it's theta over 2 minus sine 2 theta over 4. Is that a thing? It's on your card. Then this one does a weird thing that we don't usually bump into. We just bumped into some trig trivia. This picture is only equipped to give you theta-based information. It can't give you, it can give you this. But sine 2 theta is not our friend. We have a picture that can play theta games with us. Sine 2 theta needs traded, so we need to consult our card again. That's why I said this lesson is the champ of all card champs. It uses old stuff in the card, new stuff in the card, lots of stuff in the card. Somewhere on your card, there's probably a sine 2 theta makes 2 sine theta cosine theta. If that isn't on your card, it should probably go on there. That I think we bumped into that when we were doing 8.1, maybe not. Don't know. But like I said, if that's not on the card, it's worthy of being on the card. I'm gonna run out of room by a smidge, but let's see how it goes. Let's do this first. Sine theta from the picture. What's the sine of theta? X over 3. From the picture, what's the cosine of theta?
The root over 3.
The root over 3. There's also a 2 weighting, there's a 4 weighting. I thought on what could get us an angle?
What do you mean?
How can we get an angle? What kind of trig gets us angles?
Inverse trig.
Inverse trig. So you could do inverse anything you want. You'd probably rather use these two because that looks a little simpler. X and 3 makes sine, cosine, or tan.
Yeah.
Well, wait, what do you?
If we just use the x and the 3, which trig fraction is that? Sine, cosine, or tan? Sine. Sine would be x over 3. So if I do the inverse sine of x over 3, that's a way that I could describe what that angle is. The theta is referencing an angle for us. I don't have room to write it, but I'll say what I would write for the answer. Did I lose anybody on the jumping through those hoops?
So. Oh, okay. Never mind. Okay.
You good?
Yep.
So what I would do then, I would do a little bit of just tidying up here and probably distribute in the 9. Because if I distribute in a 9, 3 times 3 is itself a 9. This could cancel that if I'm willing to distribute. 2/4 could reduce to be a half. So my final answer I think I'd write would be, I'd probably slide the half. Instead of a 2 on the bottom, I'd slide a half and go half inverse sine, that fraction, minus another half x root plus c, and I'd call it a day. Actually, no, this first thing should have a 9 halves. When that 9 cancels that 9, it's still got to hit the sign. So I retract my comment for a second and go slightly. I'd go 9 halves in front of inverse sine, x over 3, minus a 1 half in front of an x and the root, and then a plus c, and I stand by that. About that.
So how are we going to do sine 2 theta again?
This picture can only answer questions about theta itself. Like we're drawing a triangle based on an angle, so it can answer this, but it can't answer something with a different argument. It can only answer things about the theta argument. A long time ago when I started, I said there was going to be something about this one that was undesirable that we'd have to remedy. Do you remember what that was? Yeah, we need the x squared to be alone, so we need to fix that. So to make this 25 go away, on the bottom we want to divide by 25. And you can do that as long as you pay for that on the top. Because in fraction land, if you want to change the bottom, you can, you just have to change the top. If I'm dividing the bottom by 25s, what would I divide the top by? 5 is correct. Because the bottom, there's a root involved. On the bottom, we've divided by the root of 25, which is in reality a 5. So this is going to start off with a 1/5 of dx, a root, an x squared minus 4/25. And now the problem's okay to start. Question about what we had to do to make that okay to start. So it's subtracting, so it's either type 2 or type 3. It's probably type 3 because I usually do one of each type on a lesson like this. Is it indeed type 3? Yes. It is. So we're going to go x equals
a 2/5 secant theta.
2/5 secant.
I didn't know you were going to put it as a sorry.
Might as well do the dx. dx would be 2/5 secant tan. Draw myself a triangle on this bottom side. 2/5 on this side, the root of the thing that we had, and on this side, an X.
It's not your day with chalk.
It is not my day with chalk. No, I got greedy. I'm just trying to squeeze it out with these little nubs. I keep throwing in more little nubs and just saving the big boy in reserve. It might be time to just make that move. New integral, 1/5 can just get out of the way. The dx would be a 2/5, a secant, and a tan. Where the root used to live, it still lives, but this is where we get our magic trick. So from the final line of the problem now has column, it would be what's under here?
Oh wait. Is it just this? No, wait, it's, wait, what's the A?
The A was 2/5,
Okay, so then 4/25.
4/25, tan squared. 4/25 is going to become in a second, like it has in every other problem, do the root to make 2/5, can wipe out the 2/5. The root of tan squared is tan, which can wipe out the tan. So we have 1/5 integral secant. Which is a lot like where we were coming in over here. We're in the same spot we were in on this problem. Integrating secant was this a minute ago. It still is. It's 1/5 ln secant plus tan. And then you don't have to do what I'm about to do, but this is my opinion. I'd rather not get involved with fractions and fractions. Okay, we were forced into this world for a second by the rule of we had to have the x squared alone for this pattern to even work. But you have two choices. You can either put a bunch of fractions and fractions into this world and fix it, or you could just fix your triangle back in this world. I'm going to just fix the triangle back in this world. Okay? If I don't want 2/5, I'd have to multiply there by 5. If I don't want under the root to have 20/5, I'd multiply under the root by 25. Is that fair?
Yeah.
Yeah. Under the root to multiply by 25, and here to multiply by 5, that's fair. As long as over here I also multiply by 5 to just have consistency and multiply the entire triangle by stuff. A simpler triangle to use would have a 5x, a 2, and the root 25x squared minus 4. That's probably a better triangle to use. You could use this triangle and save it. I don't want it.
So it's like 25 x squared plus minus 4.
So this is it's the original root we came in with.
Oh.
It'll always be the original root you came in with. We set it aside, and then it's going to want to reappear anyway.
Okay.
More dead chalk.
Look how much chalk you have over there.
A lot.
There's so much.
For just such a moment as this. From our picture, what's the secant?
5x everything.
Yeah. What is the tangent?
The root
The
everything.
root over 2. And like I said on the other one, 2 problems ago, if you wanted to make one single fraction and have it be over 2, this plus that, that's fine. I don't see any advantage in that really. And that's our day.
Okay, this is like so much. I actually liked the 8-5.
8-5 was a lot easier than 8-4.
Yeah.
For sure, for sure. Basically 8-5, I don't remember what I said in the video because it was filmed more than a year ago. It's basically like using the giantest of all the note cards that you've ever seen.
I know.
Like if you just envision your note card to be 5 pages long, that's what 8-5 was like. it is helpful for 8-5 homework, if I didn't say this either in the video, to, when you do the homework, jot down which number you used. If you didn't do that, did I say that?
Yeah.
Okay, so that's helpful information, because then you're like, why can't I do this? I did number 17, and I'm like, it's because you should have done number 18. 2 days of homework on this from this 8-4, so syllabus would know the numbers. I think it's 533 is where we live. There's an odd day, there's an even day. And I have more notes than average written on my book itself on 533. Next to 3, I wrote hard one. So when you go to do this first assignment, 1's okay, and then if you run into trouble on 3, there's something that makes 3 hard. I'm not sure what it is. 13 and 14 and 20, I wrote a note to myself, you have to do a substitution first, like a pick a U. Even on top of this, to make the problem even look like this looks, you have to go like U equals this or U equals that before you can even like go into this lesson. It's a substitution leads you into a trig substitution. So those are 13, 14, 20 probably not going to be your favorites either. But 3 was the only one that got the special note of hard one.